Hi everyone, we're going to use the information in the diagram to write a proof, and we want to prove that in this case MN is congruent to TQ, and for this one we want to prove that DB is congruent to CB, and we're going to be using the corresponding parts of congruent triangles are congruent. So we'll get started and do this one. So we're going to have our statements, and then I'll put reasons over here. Hopefully I left enough room. Okay, and we'll get started. So let's see what's given. What's given is the markings. So if you look at the markings for this one, we know that MQ is congruent to NT. That's given. Right here. It's marked. All right? So that's number one. Number two, it's also given that MQ is parallel to NT. That's given. And that's because of this mark right there. And then number three, let's see what we can do. We can say that angle NTM is congruent to angle QMT. So NTM, I'm going to erase this real quick. NTM is this angle, and QMT is this angle. So now that I've written that, what do you know? You know that that is your alternate interior angles theorem, because of the parallel lines. Remember, we have the parallel lines, so we have the alternate interior angles. So next, we can say, because of that, well, we can also say, look at this, because we're trying to show, we want to make congruent triangles. We can say that line MT is congruent to line MT. And we want to do that because these triangles can be separated out, and they still have this same side right here. So that's called the reflexive property of congruence. And then let's see what we can do next. For 5, let's state the triangle's congruency. So we know that this line is congruent to each other, like right here. So we can say by the triangle, let me do a different color. The triangle NTM is congruent to triangle QMT. And that's because of your side, angle, side. And see if you see it. This is side, angle, side. This one's side, angle, side. So that's your side, angle, side congruence postulate. And then finally, we can say that because the triangles right here are congruent, And we want to prove that MN is congruent to QT. Since the triangles are congruent, that means the corresponding, so let me just write that, MN is congruent to TQ, because since the triangles are congruent, that means the corresponding parts of congruent triangles are congruent. And that's what you write, just like that. Now the second one, let's write our statement. And I'll go down here a little bit and write the reason. And the bottom line is we want to prove that DB is congruent to CB. And we already have one ticker mark, so I'll put 2 here. All right, so let's write the given. We know that for the given that AB, so this is 1, AB line is congruent to line BE. So that's given. Secondly, we have these little markings here. So we can say that angle ADB is congruent to angle ECB. So that's given. All right, so let's see what else we can do. So we can also say that angle ABD, this angle, is congruent to EBC, this angle. So angle ABD is congruent to angle EBC. And that's, remember, your vertical angles theorem when you have intersecting lines. Also, these 2 angles here would be congruent on this side, but we don't need that. All right, next, let's see. Let's see if we can prove the triangles now. So what we have here, again, is angle. We have an angle here. We have an angle here. And we have this right here. So let me erase everything so we know exactly what we have. We have this angle. So we have angle, angle, side. And this is, we have this angle and this angle. So over here we could say angle, angle, side. So the triangles are congruent. So triangle ABD is congruent to triangle EBC. And that's your angle, or AAS, angle, angle, side, congruence theorem. And since the triangles are congruent, that means our sides are going to be congruent. So DB is congruent to CB, which is what we wanted to prove. And that's by corresponding parts of congruent triangles are congruent. And that's exactly how you write it. That's it. Thank you. Have a nice day. Bye-bye.